Alright, hey, today I'm going to talk about failed motors on Tajima Embroidery machines. So, I have two single head Tajimas. I've got some multi heads too, but they're older. And the two single heads are kind of early 2000, vintage, late 99, early 2000. One's a TMEX, the other's a TEHX. They're both relatively the same. There's some differences in the needle cases and things like that, but they mostly work the same kind of construction, same layout, same setup. And one of the things that can start happening with them is they can start wigging out, and the pentagram will stop working the way it's supposed to. One of the things that happens on mine is suddenly the x-axis will make a sudden jump off to the side. So there's a hat that fucked up that was stitched along just fine. First it does the T, then it moves on to this F, and it starts at the bottom. Sorry, I'm not used to this. Starts at this little foot here, comes across, does this little foot, comes up, and then it just went and shot over about 6 or 8 millimeters and started stitching it all sideways, and then it'll carry on fine. The other thing that it'll do, I don't have an example of it, is all of a sudden the y-axis will just quit, just stop, and it'll just keep going back and forth on the x-axis wherever it's supposed to, but no y-axis movement, so it's just sewing this line back and forth and back and forth and back and forth and back and forth until finally it piles up so much thread that it breaks and the machine stops. If I'm lucky, I can catch it and I can recover the garment. There's no guarantee that I'll even hear it. So, like, I've had it just sew a mile of thread. I had it sew out one design completely, and I didn't even notice it because I hit start and walk away, which you're supposed to be able to do. But it didn't. It didn't. So there's three things that run these motors. And these ones have one motor for the x-axis. That's a single shaft guy, and they got two tied together to do the y-axis. They have a crossbar that links the two of them together to keep them in sync. There's three things going on. There's the overall control, so like the head card or whatever you want to call it. Sorry, not the head card. That would be in the needle case, but the main control card in behind the control panel. Then there's the XY driver card, which takes the signals from the control panel and turns it into pulses to move the motors back and forth. And then there's the motors themselves. And there's a lot of people out there who just go immediately to the XY card. There's something going on, it's your XY card. First, you got to do all the regular things like clear the machine memory, load the design up brand new. Start from scratch. Make sure everything's clean. Reset the machine. Sometimes you have to go as far as reloading the machine firmware. But if none of that works, and this problem tends to be intermittent until it's all the time. And that's what happened to me. Just today, I had the x-axis thing happen a dozen times when it used to be once every 400 pounds. And then all of a sudden, it's happening all the time. The y-axis thing, it would happen a little bit more frequently, but it was so infrequent and not a discernible pattern, so I couldn't really nail it down. But when these things start happening and you've tried all that other stuff, people immediately assume it's the XY card. And I don't buy into that, because when it's working fine, it's working fine. The machine functions fine, so to me that implies that the main control card is all fine. So that leaves the motors. These are NEMA 24s, I think. I don't know. They're 60 mil by 60 mil. I think they're NEMA 24s. And there's nothing to these things. There's a permanent magnet inside them, a bunch of coils, and there's not really much that can go wrong with them. So let's take one of these things apart and see what we got. So, I'm going to start with this X-axis motor here. Cause it's the simplest one. So, it's got this little pigtail cable on it. It's a 6-wire stepper. I think that means it's a bipolar or something like that. I don't know. I read a shit ton of info on these things and I didn't absorb any of it. But when I pulled off this connector, first thing I saw was a little itty pin. Let's see if you can see that. Focus, you fuck. I don't know if you can see it, but this one pin on this one side's got some burn marks around it. So that means that pin got hot. Why? We don't know yet. So I'm going to toss that aside. These things are really simple to take apart. They just got 4 little screws. Well, there's some bearings in there. It all comes apart pretty easy, so you just got to kind of wiggle this top cover off, pull the screws out with it. There's the bearing. You can see the ends of some of the coils and whatnot in here. Then you can very carefully pull out the rotor. These are all the magnets. If you look at them, hard to see on camera. If you look at them, they don't quite all line up. This is kind of how they achieve their step. These are like 1.8 degrees per pulse kind of thing per step. It's what, like 200 revolutions per, or 200 steps per rev or whatever. Put that over there. There's a little wafer spring in there that kind of keeps everything in line. Great thing about that permanent magnet is it just kind of sticks there. And then there's the back cover. It slips off the same way. So, unlikely that the motor is going to lose any of its magnetic field. It's permanent magnet. And if that fails, something else has really gone sour. The rest of this, like, there's 2 covers. There's a couple of bearings. Sure, the bearings could go on you, I guess. It's easy enough to replace. I would guess. I haven't looked for any, but then all that's left is the stator, the housing, or whatever you want to call it. And it's made up of a whole bunch of loops of magnet wire. Magnet wire is insulated wire. They wind it in certain patterns to make the coils. Now, this stuff can't really fail. Like, unless you got a motor super hot, and you'd know because it would have started smoking, maybe lit shit on fire. But if none of that happened, then there's not really anything that can go wrong with these magnet coils, unless they were made poorly to begin with, which usually isn't the case. I mean, these things probably have some sort of QC control at the factory. So, what's left? Well, there's these pins. Nothing much can go wrong with pins. They're just pins. And then if we get to pop off this little cover here, dropping shit. There's a little circuit board back here with solder points. Now, that can fail. What can happen here? We can have delamination, we can have cold solder, there can be all kinds of fun shit go wrong. Interestingly enough, when we're looking at this circuit board, we see that there's actually 8 coil wires coming off. And what that means is this is actually an 8-wire stepper motor that on this printed circuit board they have designed the traces to combine the two center taps. There's some words I did remember from stuff I read about stepper motors, to turn it into a 6-wire. So it's actually an 8-wire that they've turned into a 6-wire. So what that means is if you're looking to replace one of these motors, you can just go get a NEMA 24, I think. NEMA 24, I think the body is 65, so actually measure the complete length. So it's like an 86 mil. I think that somehow turns into like 80 or something like that. Anyway, you can go get a generic stepper motor. I think I found some online for like 25 bucks. And all the embroidery machine places, they try to sell these things for hundreds, which is ridiculous. So if you're looking to replace one of these things and you're feeling adventurous, don't do it on anything that's got a warranty. You can get just generic stuff. You don't have to fuck around with super expensive motors. So, but I don't have any motors to replace these with. I need a working machine, so I'm going to look a little closer at this circuit board. So the pins that we looked at right here, they poke all the way through the circuit board right to the back here, and they solder, and we can see that this one is a little bit corroded, burnt. I don't know if we can get in on that, but I don't know. It's the first video I've ever tried to make ever, so whatever. It's just a stupid, shitty little circuit board, and it doesn't do anything but connect these magnet wires to these pins, so you have a convenient cable connection. So what we're going to do is we're going to fix this. There's lots of room in here. There's lots of room behind this little cover. So what we're going to do is we're going to take some of this wire. This is like 22 gauge. Yeah, 22 gauge insulated wire. This stuff you can get at any like electronic hobby shop. Use it a lot for like screwing around with breadboards and things like that. But it'll also work really good for this. So basically what we're going to do is we're going to desolder these points a little bit. Then we are going to hit them with a little bit of emery cloth and kind of clean up these solder points here. And I'm basically just going to solder a bridge from each of these magnet wires to their corresponding connector pin. And what that's going to do for me is just going to bypass the shitty trace that's delaminating under the bottom of this circuit board, and hopefully give us a good connection and return these things to working order. So I have everything I need here except for some emery cloth. Soldering iron. Now ideally what I should have is some of that desoldering tape, or it's that kind of like foil braided stuff, but yeah, I don't have any, so we're gonna wing it. Some flux on the tip of the screwdriver there. This is not a soldering tutorial. There's probably 75,000 of those on YouTube. Go ahead and find one. Do a little bit of solder, flux to help come. That stuff going. So now what I'm going to do is I'm going to just cut off a chunk of this wire. Going to strip a bunch of it back. And then, let's see, some solder here. Canada, we're lucky. We can still get solder that's got lead in it. Works a lot better. So I got the emery cloth. I'm not going to use it if I don't have to. Because if I'm lucky, I should be able to just get this warmed up. Melt this out. So basically what happened there is I was able to get the glob of solder that was on this pin already to grab the wire, and I didn't have to add any extra solder. So that's cool. So now that's held on there, so maybe I can heat up this little spot right here. These are known as cold solder points. Correction, cold solder points are the problem. So, got that one's hooked up. So right now this outside one is one of these 2-into-1 spots, so that's where it's getting a little tricky. But we're gonna make this work. So let's get that board off right there. A little bit more insulation away. Just a bit more time. Looks like that worked out. Take our screwdriver, bend this over. Down there. Let's get a little more flux. A bit more up here. That's a nice good connection. Now this definitely is not pretty, but I've done this before and it worked. So there we go. So see, here we go. Focus back. Yeah. Oh well, whatever. Sorry, it's blurry, but you can see how I got just 2 little wires added in, connecting that one pin to those 2 magnet wires. And all I gotta do is do that 2, 3, 4, 5, 6 more times. Super fun. Oh yeah, and then I get to do it on 2 more motors. Isn't that awesome? super blobby and not real pretty, but like I said, this is not a soldering tutorial. Oh, if you're not comfortable enough getting the motors out of your machine, I don't suggest doing this either. Find a tech, get them to either fix your machine or convince them to do this. This is not for the faint of heart. And fine, once you get the rhythm, it's a lot faster. See? Sorry, I don't know how to make your GoPro focus. See? Not pretty, but works. And if you are comfortable doing this kind of work, and you already have all your equipment, like soldering irons and all that kind of stuff, this is damn near free. Just takes a bunch of time, and you gotta pretty much dismantle the machine completely. But if it works, save a whole bunch of money. There we go. If you want to do this a different way, go right ahead. The main idea is to connect those little wires to those pins as goodly as possible. I've done this before. It works. There's probably 100 different ways to do it prettier, better, different, whatever. But as long as you didn't overheat your motor and let the smoke out, this is all fine. It's just these shitty little connections here. Alright, I'm going to do 2 more motors. Bye, everybody.